Hello, my lovely viewers. Welcome again to Mathematics and I. It is your presenter, Jefferson. And today we are staying on the topic solving simultaneous equations problems. But right now we shall be using the matrix method in solving simultaneous equation. Now don't forget that we've talked about elimination method, we've talked about substitution method. But right about now we shall be using matrix method in solving simultaneous equations. Now before you can go about this, there are some things that you need to know. There are some things that you need to solve for before you can use matrix to solve what? Simultaneous equation problems. Now, it depends on the numbers of variables that is given in the question. Remember we said from the beginning of the class that simultaneous equations involves two or more equations or two or more variables. Now, the number of variables present in the equations tells you the number of equations you have. For instance, you will see that the previous examples that we'll be solving using eliminating and substitution method, it was always two variables, x and y. Now, the way you solve for two variables using matrix method is different from the way you solve for three variables using matrix method. But today we shall be looking at matrix method involving two variables, which is also x and y. Now, the first thing that you are going to find when you are using matrix method in solving simultaneous equation is change. Is your change. Now, how do you solve for change? It is simple. Simply looking for the determinants of the coefficients of the variables x and y. That is how you solve for change. Now, the next thing you solve for is change in x. Change in x. Now, how do you solve for change in x? Now, it simply means replacing your coefficients of x with your constant and then finding the determinants. And then you have gotten your change in x. Now, after change in x, the next thing you look for is change in y. Change in y. Also, replacing the coefficients of y with your constant and solving determinants. Now, once you are able to get your change in x and your change in y, now for you to be able to get the value of x and y, it has a formula. Now the formula is, to solve for x, the formula becomes change in x all over change. And then, to solve for the value of y, the formula becomes change in y all over change. You see, this is why it is important to first look for change in x, and change in y. Because if you don't know the values of these three things, there is no way you can get the values of x and y. Okay, now that we have explained this, let us use two examples, to see how this thing really works. Two examples. And I bet you after these two examples, you will know how to use matrix method in solving simultaneous equation problems. Okay, now let us assume the first question is 4x plus 2y equal to 1. Okay, and let's say 2x minus y is equal to 2. Now let us say this first question. Let us solve this question using matrix method. Now, how do you go about it? Please stay with me. Now, you will notice that there is nothing matrix about this question. So the first thing you are expected to do is to bring out the matrix from these equations. And how do you do that? Let us begin. We are going to have something like this. Now, the coefficient of x here is 4. The coefficient of x here is 2. Now, the coefficient of y here is 2. The coefficient of y here is minus 1. There's an invisible 1 there. Then you close your matrix bracket. Are you there? Now, after you brought this out, the next thing you bring out is the variables that are involved in the question. Now, the variables here is x and y. So I'll come here. X and y. And then I'll close. And then, what is the next thing we'll do? This is our constant. Equal to our constant, which is 1 and 2. Then I close. Now you see, we are bring from equation to matrix. This is how matrix look like. Now, once you are bringing it out from this form to this form, what are the three things that we are expected to find first? Remember I said, we solve for change. After we solve for change, we solve for change in x, and then we solve for change in y. Now, it depends on the variables involved in the question. If it was m and n, it means we're going to solve for change in m, and change in n. Now, without wasting time, let us solve for change. Now, remember I said To solve for change simply means taking the determinants of the coefficients of x and y. And don't forget, 4, 2, 2 minus 1 are the coefficients of x and y. So I'll come here. Now the determinants of 4, 2, 2 minus 1. Now, how do you solve for the determinants of 2 by 2 matrix? Because this is a 2 by 2 matrix. We have two columns and then we have what? 2 rows. 2 by 2 matrix. Now, how do you solve for the determinants of 2 by 2 matrix? It's very simple. You use 4 to multiply minus 1. 4 times minus 1 will give us minus 4 minus. Now you use 2 to multiply 2, which is also 4. Now class, minus 4 will give us minus 8. So it means our change is minus 8. How did I get minus 8 again? 4 times minus 1 gives you minus 1. Whenever you are looking for the determinants, you must minus. Minus 2 times 2, 4. Now you are owing 4, you are owing 4. How much are you owing? 8. Okay, now that we have solved for change, what is the next thing I said we look for? Change in x. Now let's go there. Now, how do you solve for change in x? Change in x simply means, remember, this first column here belongs to x. Now, when you say change in x, look at the word change in x. It means remove the column of x and give your constants there. Replace it with your constants. So I'm going to have something like this. Now, instead of writing 4, 2, I will write 1, 2. I have changed x. Now, what is the next I have here? 2 minus 1. Also, I find the determinant. Now, the determinant again becomes 1 times minus 1 gives me minus 1 minus 2 times 2 gives me 4. Class, minus 1 minus 4 gives me minus 5. I have got to change in x. Now, the next thing we look for is change in y, which is the last variable. Now, change in y simply means replacing your y column with your constant. Simple. So, we're going to have something like this now. 4, 2. Now, instead of writing 2 minus 1, I'm going to write 1, 2 because I've changed it. Now, also looking for the determinant, 4 times 2 gives us 8 minus 2 times 1 gives us 2, which is 6. Okay, now we have fulfilled the first step, the first stage, which is solving for change in x and change in y. Now, remember the question is not solving for change in x and change in y, but rather the question is solving for the value of x and y. And then don't forget, I gave you the formulas for solving x and y. I said, for x, the formula is change in x over change. Now, when we do that, we're going to have this. Now, change in x. Look at change in x. Value of change in x is minus 5 over change is minus 8. So, class, when minus cancel out minus, what is the value of x? 5 over 8. Now, let us proceed to find the value of y. Now, finding the value of y, it also have a formula. The formula says y is equal to change in y over change. Now, which means change in y is 6 over change is minus 8. Now, something can divide 6 and minus 8. What is that? 2. Now, when 2, first of all, there's a plus sign here. Plus divided by minus will give us minus. Now, when 2 cancels 6, I'm going to get 3. And when 2 cancels 8, I'm going to get 4. Therefore, x is equal to 5 over 8, comma, y is equal to minus 3 over 4. This is how you apply matrix method in solving simultaneous equations. First of all, solve for change. Solve for change in x, and then solve for change in y. And after this, you apply the formulas for x and y to get their values. It is as simple as that. Now, to make you get a proper understanding about this, we are going to solve another example. Another example to see how it goes. Okay, question number 2. Don't forget to subscribe to our YouTube channels. Don't forget to share. Now, question number 2 says, I have 6x minus y equal to 2, and then I have 2x plus 2y equal to 1. Now, we are also applying matrix method in solving this problem. Now, what did I say the first thing we do? Bring out this form and make it becomes a what? A matrix form. Now, we're going to have this. The first coefficient here is 6. We have 6. Now, what's the coefficient here now? Minus 1. There's an invisible 1 there. So, I have minus 1, I have 2, and then I have 2 here also. And then I close. Now, what are the variables involved? The variables involved are x and y. Then I close. equal to, what are the constants? 2 and 1. I close. Okay, now we'll bring it out in matrix form. What did I say the first thing we solve for? Change. How did I say you solve for change? Taking the determinants of the what? Coefficients of the variables, which is this. So the determinants of 6 minus 1, 2, 2 becomes 6 times 2 gives us 12 minus 2 times minus 1 gives us minus 2. Now, I have two minus sign here. Minus times minus will give us plus. So what do we have? It becomes change becomes 12 plus 2. And what is the answer? 14. So it means the value of change is 14. Now, what is the next thing we solve for? Changing x. Now, solving for changing x. Changing x simply means replacing your x column with your constant. It's as simple as that. Then take the determinant. So here becomes, instead of writing 6, 2, I will write 2, 1, and then here remains minus 1, 2. And then I close. Now taking the determinant, we're going to have this. Here becomes 2 times 2 gives us 4 minus 1 times minus 1 gives us minus 1. So what do we now have? Change in x becomes 4 plus 1. How did I get plus? Minus times minus gives us plus. So what is the answer? 5. Now, the last thing we're going to look for is change in y. Now, solving for change in y, we're going to have this. Replacing your y column with your constant. So we have this now. 6, 2, and then here becomes 2, 1. And then we'll take the determinant. Now, the determinant becomes 6 times 1 gives us 6 minus 2 times 2 gives us 4. And what is the answer? 2. Okay, now that we have got the values for change in x and change in y, what is the question? The question says find the value of x and y. Now, what is the formula for x? Change in x over change. Now, let's do that. Now, change in x was 5 over change was 14. So our x becomes 5 over 14. Now, let's go forward to solve y. Y becomes change in y over change. Now, change in y is 2. And our change is 14. And I believe something can cancel 2 and 14, which is 2. 2 cancel 2, 1. 2 cancel 14, 7. Therefore, x is equal to 5 over 14. Then y is equal to 1 over 7. Now, class, now you can see how you can solve simultaneous equation problems using matrix method. Now, in our next video, we shall be looking at simultaneous equations involving 3 variables. 3 variables. All through the videos that we have been doing on simultaneous equation are equations that involve just 2 variables, x and y. Now, next video, you'll be seeing things like MNP, X, Y, Z, 3 variables. And how can you use matrix method, elimination method in solving this type of equation. Now we have come to the end of today's class, and I believe you have learned something new today. Please don't forget to share this video. Don't forget to comment. Don't forget to like. Till we meet again in our next video. God bless you.